So variables in the formula questions feature of Canvas can also be exponents and subscripts and stuff like that. So if we create a new question, and let's paste one that I used earlier, it says the nucleus of an unspecified isotope with a mass number of 177, so 177 in the top position for the nuclide symbol, emits 4 alpha particles and 4 beta particles. How many nucleons remain in the final daughter isotope? And you can phrase this however you want that makes sense, but this makes a really fun problem from a teacher perspective because you get to see that the 177, of course, we want everybody to have a different number. So you can put, let's just say M for the mass there, but you also want it to appear here. So you can put that as M here, and let's get rid. Okay, so now it's in exponent position. So both of those will change to be the same number. So the mass number is going to be some number between the range you specify. You also have a certain number of alpha particles, I'm using A, and a certain number of beta particles. And we know that beta particles are massless in the sense of having 0 for the change in the mass number. So this is going to test students' abilities. I should use B here. Students' abilities to draw those out and see how changes happen for nuclear decay. So we have our variables here. Of course, once I click on formula questions, already they're going to pop up. And let's say we want our mass number to be between 150 and maybe 220. And of course, we do not want a decimal place for the mass number. So having that control is good. We want a solid integer for the mass number of the isotope. And then we have to think about how many beta particles and alpha particles are emitted. So you can put any range here. Let's just say 3 to 7. And that's also going to be an integer value. And then for the beta particles, they don't actually affect the equation, but you can still have it randomized, let's say between 1 and 6. So when you recompute, it just gives you example values. Down here, we are going to want our answer to be the mass number that is generated minus the number of alpha particles times 4, because every alpha particle takes with it a mass of 4 nucleons. So that's going to be the mass number that is generated minus 4 times A. And if you want to use this potentially again, you can also subtract away 0 times B. We can save this, and we get 146. Now, this is going to be an exact number, so it doesn't make any sense, in my opinion, to have a margin of error there because these are integer values. But we do want to generate a certain number of solutions, so let's say we just generate 15 different values here. And those get generated, and then you get to see what they are down here. So we're going to update that question, save it, go to preview, and we can see that we have an unspecified isotope with a mass number of 188, and the 188 is up here, so that's pretty neat. And it emits 3 alpha particles and 2 beta particles, and the student would put in 3 times 4, which is 12, but 12 subtracted from 188, so the answer should be 176. We submit quiz, and we got it right. So that's just one more way you can use formula questions to beef up your assessments.